We're talking about two different things: writing equations, okay, and solving equations using addition and subtraction. Okay. So in the first part of your test last time, what we talked about writing expressions. Now we're talking about writing equations. What's the main difference between the two? Yeah.
One has an equal sign.
Exactly. Expression does not have an equal sign. Equation does. So that's the only difference in this section. That's why we're going to go real fast through. Okay. Because writing an equation involves an equal sign because it's an equation. So things that mean equal when we're writing equations, is, equals to, is the same as much as. These all things when we see in words, we put an equal sign. Okay. So for example, if I was to write a number is equal to 5 algebraically, in place of a number, we would put a variable, right? And when we see the word is, what do we write? Or is equal to? We write an equal sign and then to 5. Okay. Things that mean addition or things that mean to add, things like plus, added to, the sum of, more than, greater than. Whenever we see these words, we always know to write an addition problem. Okay. So for example, 6 added to a number is 13. Okay. So when we have 6, we just write the number 6. Added to is the operation addition. A number, we use a variable. And when we see is, it's equal. And 13, number 13. So we're going to talk today about solving these. Right now we're just writing them. Okay, writing these equations. Things that mean subtraction. Remember, minus, subtracted from difference. If you hear the word difference, that's the answer to a subtraction problem. Okay, less than, less, and so forth. Multiplication, the product of, product is the answer to a multiplication problem. Times, multiplied by, twice, or the word of. Okay, that was one area missed on our test. When we saw the word of, a lot of us wrote division. Of means multiplication. Okay, we'll go over that later. And division, the quotient. Quotient's the answer to a division problem. Divided by, divided into, those sort of things. So if you had to write this in an equation, 6 more than a number is 20. Anybody want to take a stab at that? What that would look like? Yeah, Jared.
X plus 6 equals 20.
Exactly. X plus 6 or 6 plus X equals 20. The reason it doesn't matter the order is because addition's commutative, right? You can switch around the order. Okay. So X plus 6 or 6 plus X is 20. Now here, 2 less than a number is 14. This is subtraction because it's talking about 2 less than something. But order does matter here in subtraction. Okay. Anybody want to take a shot at this one? Order does matter here. Yes.
X minus 2.
Yes, exactly. X minus 2 is 14 because it's 2 less than a number. Like, for example, if I was going to say, what's 2 less than 100? You would say 98 because it's 100 minus 2. Okay? So just because something comes first, the 2 less came first, that doesn't mean it's minus 2 minus X or 2 minus X, right? So 2 less than a number X, so X minus 2 is 14. How about 4 less than twice a number is 5? 4 less than twice a number is 5. Any guess on there? Well, if we're going to do 4 less than, right, we have to take away 4 from twice a number. When we write twice a number, we can write things like 2x, right, or 2 times x, 2 times n. The variable doesn't matter. Twice a number, 4 less than that is equals 5. Okay? The sum of twice x and 3 times y is 60. What's sum? The sum is the answer to what type of problem? Addition, right. So sum of twice x and 3 times y is or equals 60. Good. Last one here, the square of a number minus 3 is the same as 2. So if I'm going to square a number, what exponent is that? 2. A square number, exponent of 2. So the square of a number minus 3 is the same as 2. Very good. Okay. So if you were going to go the other way, I gave you an algebraic equation. You had to give it to me in words. There's a bunch of different ways you could give this to me in words. What would be one way?
5 times a number.
Yep. Yep.
2 equals 1.
Right, that's very good. 5 times a number plus 2 equals 1. You could have also said the sum of 5 times a number and 2 is 1. Or 5 times x added to 2 is 1. Okay? Those sorts of things. There's a bunch of different ways you could do that. The other thing is now how to solve these problems. Okay? And we do that with the addition or subtraction property of equality. What that says, this is the formal definition. If you have 3 numbers and 2 equal to each other, if you add the same thing to both sides, it remains true. So for example, if you have 20 equals 20, that's a true statement, right? If I add 5 to the left-hand side of the equal sign and add 5 to the right-hand side, it's still true because 25 still equals 25. right? So whenever you have an equation, if you add something to one side, you always have to add it to the other side to keep it true, okay? We use that to solve these types of problems. So x minus 3 equals 7. When I say solve an equation, what are you trying to do?
Figure out the.
Yes, more specific though even. Solve this equation means you're going to do what?
Find x.
Find x. You're going to solve it, find what x is equal to, right? So to do that, we have to get x by itself on one side of the equal sign, which means we have to get rid of this subtracted by 3. We do that with the inverse operation. What's the opposite or the inverse of subtracting 3? Adding 3, right? And whatever we do to one side of the equal sign, we have to do to the other. So a lot of you have probably seen this before. Excellent. That side becomes 0. You're just left with x. 7 plus 3 is 10. That would be my answer because I solved this problem. Now you can always check your answer. You could go take that 10, plug it back in for x. 10 minus 3, that's 7. Yep, I'm right. Okay. So you always, when you solve it, you try to get x positive and by itself. Okay? By itself. So in this case, x plus 2, or x plus 6 equals 2. I want to solve it. What do I need to do to both sides to get x by itself?
Subtract 6.
Yeah, subtract 6. Because I'm adding 6 to x, I just do the opposite of that. Subtract 6, that becomes 0. If I have $2, I take away 6, I'm in debt $4. Here, I still am trying to get x by itself. I have 11 plus x, okay? But I need to move this 11 to the other side to get x by itself. So how do I move that positive 11 over? I have to subtract it, right, because it gets it equal 0 there. Subtract it from both sides. I'm just left with x on this side. If I have negative $5 and I take away 11 more, I'm now down 16. Okay. Now a little trickier when something like this happens. Okay. Because a lot of us, we may look, okay, to get x by itself, let's say you would subtract 55, and as long as you do it to both sides, you're not wrong. That would go away. This would be 15. But what would I be left with on the left-hand side here? I'd be left with minus x, because remember, you always have to keep the sign that's in front. Okay? But I don't want what negative x is equal to. I want what is positive x equal to, or x by itself. So a lot of you may know how to get rid of this negative 1 that's in front of the x. One thing you can do is multiply or divide both sides by negative, right? But let's say we didn't know, because we haven't talked about it yet technically. Let's say we didn't know how to multiply or divide by negative right now. And I want to get rid of this negative x to solve for x. Okay? One thing I could do is I could just add x to both sides, because then that's going to make it a positive x over here. I'm left with 0 equals 15 plus x. Now if I wanted to solve for x, what would I have to do to that 15? Move it over. I'd have to subtract it. So then I get negative 15 equals positive x. Okay? It doesn't matter which side the x is on, if it's the right or left, as long as it's positive by itself. But going back to here, let's say again you didn't know how to divide or multiply by negative. We could have just done that at the beginning to make it a positive x. Let's move that to the other side. We're left with 55 equals 70 plus x. Then we'll just move that positive 70 over by subtracting it, and negative 15 is x. Okay? So whenever you have a negative x, you need to make it positive. I want to know what positive x equals, not negative. Yes?
Why did we subtract 55?
I just did that to show you what would happen.
Could we have added 55?
Good question. If at this point you add 55 to both sides, that's still going to make the equation true, right? But 55 plus 55 is 110 minus x equals 125. I haven't really made any progress to getting x by itself here. Does that make sense? Okay. That's still true, and I would still get the same answer if I kept working it. But adding 55 doesn't get the variable by itself, where subtracting 55 would. Okay. Good question. Other questions here? All right, we're going to do 2 more when we come back from lunch and then play a short game. So just because it's a fraction, nothing changes. Okay. If we're still trying to solve this problem, which means we're trying to get the variable by itself, positive on one side of the equal sign. So if I'm subtracting 1/3 from this equation, what should I do to both sides to get x by itself?
Add 1/3.
Exactly, add 1/3 to both sides. That goes away. I'm just left with x here, positive, which is what I want. Okay. 2/5 plus 1/3. Remember, when you add fractions, you need common denominators. So, right, the common denominator is going to be 15 here, which means you need to multiply top and bottom here by 3, top and bottom here by 5. So you get 6/15 plus 5/15, and add that together, that gives you 11/15. Okay, I got 6 because of 2 times 3, I got 5 because of 1 times 5. So just because it's fraction, nothing else changes. Same thing with decimals. To solve it means to get the variable by itself, positive on one side of the equal sign. Okay. All right, now we're going to play this game called crisscross.